Kiwi.
The Radio Wemo Breakfast.
And we're staring into the night sky now. Dylan Storey, Dylan Storey's Astronomy. We're going hunting, in fact, for satellites and space stations. G'day there, Dylan.
G'day Wemo, g'day listeners.
Now, I saw you tweet just the other night. You were lucky enough to manage to catch the space station going over the top of Auckland.
Yeah, you can see it fairly regularly, but I just happened to be out. I was actually at the Star Dome doing telescopes with a group of people and looking at things in the sky, and all of a sudden someone says, "What's that bright light moving? Is it a plane?" And you can kind of see that it's definitely not a plane.
Yeah.
And it was coming in from the east, maybe slightly north, maybe slightly south of east, and it came directly overhead, and we had enough time to go back into the building and round up all the people in there that were still hanging around looking at the displays, and they all came out and saw this wonderful space station pass over.
And of course, with the naked eye.
With the naked eye, it was really bright. When I say really bright, I mean magnitude 3.7 to be precise.
What does that mean?
That is so the brightest stellar-looking object, which is Venus, will get up to minus, I think it's 2.5. So this is it's sort of basically almost double as bright as Venus ever gets. So you could compare it to when you see a plane landing or something, when you see a plane off in the distance, that sort of bright light that's brighter than any star or planet.
Yeah. Okay, well that's fairly significant. And how?
It's fairly significant, yeah. And it the cool thing is it kind of changes brightness as it goes over. It gets brighter and dimmer, and that would be because it's basically flat. The bulk of it is flat because it's the solar panels which spread out, and they spread out to the size of a football field.
Oh, it's big.
Yeah, it's really big. And so the part that the people live in is much smaller. It's in the centre, but it's basically as the angle of those solar panels changes, then you're getting better or worse reflections from the sun.
Okay.
So you sort of see it. You sort of see the brightness swell and intensify as it goes along, and then as it gets to the other side of the sky from where the sun is, it suddenly disappears.
So you'd only see it, I'm guessing, sort of just after sunset and not long before sunrise.
That's right.
Yeah,
that's right. It's in low Earth orbit, so you only see it sort of shortly after sunset or sunrise, or before sunrise. And it's quite cool seeing it disappear at the other side of the sky. It just seems to just wink out in the middle of nowhere.
Yeah.
And that is, of course, because it's then entered the Earth's shadow.
Right, of course. How fast is it going? I mean, because you were able to run back inside, grab a whole lot of people, and come out, and they could still see it. So, I mean, is it crawling across the sky? How would you describe its speed?
It's significantly moving. Like, I think it spends about. In fact, I've probably got the information here of how long it spends in the sky.
Mm.
That brings me on to the next point, that it will be visible again tonight. So you can go outside and see it at 20:57, so 8:57 tonight.
Anywhere in the country?
Yes, I believe. The chart I'm looking at is for Auckland, but you will still see it from, say, Wellington. The further away you get from Auckland, the harder it will be to see. There are charts on the internet for every specific area.
Yeah.
I'm looking at a link off the Stardome website, stardome.org.nz. Go to Sky Guides, go to Satellites in the Sky, go to ISS tonight.
And what kind of orbit is it? Because I mean, if it was in like I would imagine if it was in a steady, stable middle of the Earth orbit, right, it would just be going around the same spot all the time. But that's obviously not the case. It's got to be off kilter in order for it to keep changing the ground that it's going over. Can you describe
that's
that?
right. It's in a kind of diagonal orbit. If you picture the map of the world, it's kind of going diagonally across, and that line changes, sort of moves. Forget if it's east to west or west to east, but it's diagonal line. Its path changes night to night, and there's a sort of resonance. So because it was seen on, when was it, Wednesday night, so it will be seen again tonight on Friday, and it will eventually it's around every few weeks, but you'll get a high pass, and an overhead pass in a certain resonance.
Yeah.
So tonight it will be in the sky till 9:03. So you got basically 6 minutes to see it. So that's quite a bit of time to be passing across the sky. But you can still see that it's definitely moving at quite a decent speed.
And it is the largest thing orbiting the Earth, isn't it? So so you're going to be able to see this more than you would other satellites.
Yeah, much more.
Mm.
Yeah, you can't miss it. So if you're out there at 8:57 tonight,
check it out. And also on the Stardome Observatory, I noticed there's not just the timetable for the space station, but a whole variety of satellites that you can spot.
Yeah, there are all sorts of satellites. So any given night you can see quite a few satellites. That's just a few prominent ones.
Mm.
They'll be about the same brightness as one of the sort of secondary brightest stars.
Yeah.
So the second brightest stars in the sky, and so you can see them. They could be higher, so they'll be moving slower than the ISS. They can often be mistaken for a star that slowly moves.
It looks like
and
that,
again,
doesn't it? Mm.
Yeah, and again they'll sort of sometimes they wink out as they enter the Earth's shadow, and of course the higher ones can be seen later into the night.
Mm.
Or the opposite. If they're moving the other way, they can just suddenly appear out of nowhere as they enter the light.
Yeah. Okay, all right. Well, go and check that out. 8:57 this evening in the night sky. Look out for the International Space Station, and of course, check out all the timetables and what up at the Stardome Observatory website, which is stardome.org.nz. Follow the links from there. Thanks for.
If you're sky watching, we've got the Geminid meteor shower on the 14th.
Yep.
Which should be pretty cool in the constellation Gemini, which will be rising before midnight in the east. So that's where it would be a fairly late night vigil if you were going to see the Geminid meteor shower. And of course, the big event is in just over a week, or just under 2 weeks. The lunar eclipse on December the 21st.
Cool, and we'll talk about that one, no doubt, next week. Thanks, Dylan.
All right, thanks, Swemo.
Dylan,
Next week.
See ya. Dylan Storey's Astronomy there. Time now on QE is